Okay, so let us all welcome Professor Chandra Pradhan. His title of talk today is Recent Advances in Post-Harvest Processing of Oilseeds. After completing his B.Tech from CAET, Dr. Pradhan completed his M.Tech in Post-Harvest Technology from Indian Institute of Technology, Kharagpur in 2004 and Ph.D. from Center for Rural Development and Technology, IIT Delhi in 2011. He has been awarded with a graduate student exchange program fellowship to study at University of Saskatchewan and Canada in 2008. He's also a recipient of Jawaharlal Nehru Award for Outstanding Doctoral Thesis Research in 2012 by I.C.A.R. Till today, he has published almost 100 plus internationally reputed journal papers. He has 3 patents to his credit, and he has other, book chapters, conference proceedings, and other stuff to his credit. He has advised 6 PhD and 5 M.Tech students so far, and currently has 7 PhD students working under his guidance. With that, I will request Dr. Professor Pradhan to begin his talk. Professor Pradhan, it's now off to you.
Okay. Thank you, sir. Namaskar to all my teachers, seniors, friends, juniors who are online now or will be joining very soon. So, thank you, Bhubaneswar sir, for giving me this opportunity to share some of my technical knowledge with this CAET or OUT group. And for that, thank you so much. And I'm directly starting my presentation. So is my presentation visible, sir? Just
Yes,
visible.
yes, visible, and it's very nice. All the blinking is very nice.
Okay. Thank you, sir. Thank you. So today my topic or my talk is on post-harvest, particularly the post-harvest processing of oilseed and some whatever the recent advances or recent research is going on. Based on that, I'll be speaking. And presently, as Devus already introduced me, and a professor in the department, where our department is a young department in 2014, it started. And I am also looking after another means the administration that is associated in academic PG and research. Also, I'm looking after IIT Rourkela. Okay. So with this this processing of oilseeds, so we know that among all the key crops that is available in India, particularly or the whole world, this oilseed have the highest scope to create significant value. That is what the oilseed play an important role in Indian agriculture. So this oilseed is the, you can say, the second largest crop that next to other food grains in terms of the production, that is 125 million ton around of oilseeds, and around 50 lakh ton of non-edible oilseeds are also there, edible and non-edible oilseed. So out of that, if you see the this oilseed processing industry or oilseed, so there is a huge potential employment generation, that is up to 30 million in farming, seed collection, oil extraction, and other associated activities, or maybe more employment generation coming up in next 5 years. So with that scope, the higher output in oilseed crop that can help improve the Indian agricultural productivity and the farmers' income. So if you see the scenario of oilseed crop, particularly the India, so we have many oilseeds are available, and day by day, you can say it is increasing. So you can say as of 2021, so India had nearly 29 million hectares of land area for the cultivation of the oilseeds. Despite this high cultivated area, India remains the largest importer of the edible oil in the world. Okay, so that is the vegetable oil is that the third biggest import item after the crude oil or the gold in the country. Okay, if you see the import thing, and the government of India is extensively promoting the cultivation of this oil seed to various farmers, and you also providing various you can say incentive to endure this switch. So in this contest, you can say that if you see the global contest, India is one of the major producers of the oil seeds, which are the second major agricultural crop in terms of your tonnage and value. And for processing of these oil seeds, or you can say that the oil-bearing material, India has a large network of oil mills employing more than 10 million people. Okay, in spite of all these advantages, or you can say that in spite of a variety of oilseed that is grown, maybe particularly we are talking about the edible oilseed, but non-edible oilseeds are available. So inside a variety of oilseed grown, other oil-bearing material produce a huge network of oilseed processing industry exists in the organized sector. So in spite of those things, we have various loss due to improper processing, particularly whatever the loss happening in case of the oilseed processing or the oil yield. So one of the major factor is the improper processing of oilseeds. Okay, so because of that, some major constant I have given. So that is inefficient processing. So our processing technology not efficient, you can say. Then inadequate utilization of some oil-bearing material, maybe byproduct of the your oilseed industry, or you can say that the waste of the oil-bearing materials. Okay, so those are not utilized properly. Or another reason that is unscientific and inadequate storage. Because of that, various losses are there. Then exploitation of oilseed-based protein is not there still now. Whatever the oil cake that you are getting, or the oil byproduct waste are there. From that also you can extract the protein. Then inefficiency and expensive packaging material is another constant. Inadequate research and development is there because of that is what the post-harvest processing role is coming. And problem in exporting oilseed materials are big hurdles in increasing oil yield in the country which need attention. With this constant, I am moving forward. So for the solution or some of the solution with this post-harvest technology. What are the solution, or we can see that this post-harvest technology or the post-harvest engineering that play a key role in minimizing the loss during handling, processing, preservation of oilseed. So whatever particularly that unit operation that we are doing, so through the efficient, you can say efficient post-harvest technology, that can be the loss can be minimized at the time of handling, at the time of processing, at the time of preservation, other operation. Okay, by adopting the proper post-harvest technology, the input of cost in processing of oilseeds reduce and oil yield. Our intention is to the oil yield is to increase and the quality, obviously the quality should be good. So beside several value-added products that can also be produced even at the rural level by introduction of appropriate post-harvest technology. Therefore, the farmers can be motivated to grow more oilseeds. So with this post-harvest technology, so I'm just directly going to the various technology or various unit operation or various operation that is commonly done to the oilseed processing, particularly this handling, drying, storage, grading. These are you can say the primary processing type of thing. Then pre-treatments, this cleaning, dehulling, your size reduction or flaking, heat treatment. So these are the, you can say, given secondary step or secondary processing, that is to get the high oil yield. And some of the technology of the oil recovery is particularly the GIAN, expeller, solvent extraction, other things. Okay, so we'll be going briefly. I'll be going all detail regarding how this post-harvest operation is done. Okay, so what about that post-harvest operation? So that I told. So irrespective of the method of oil separation used or the oil extraction used, certain pre-treatments of raw seeds are essential. Okay, so I'm not going on this handling, drying, storage, grading, because these are the primary processing, and for all other food grain, including your cereal, including pulses, including your oil seeds, the handling, drying, storage, cleaning, grading, these are very much important. Okay. So just I'm going to the particularly what pre-treatment or what technology is required, particularly for the oil seed processing. So that is what the pre-treatment is coming. So to get the highest good amount of oil or the quality of oil, this cleaning, dehulling, size reduction, heat treatment. So these are the pre-treatment given before taking the oil seed to the oil separation. Okay. So here, so what about the cleanings? Because due to improper, if improper cleaning is there, obviously there is a low yield of oil will be there, and the quality of the oil will be less. That is known to all. It is applicable for all the food grains, including this oil seed. Then coming to the dehulling process, in the dehulling, that is otherwise called decortication, that is to remove the outer layer or the seed coat of the, you can say that the oil seeds. Particularly, we know that all the oil seeds, they contain some of the seed coat, and there is a kernel, where the kernel have a good amount of oil as compared to the hull. Or you can say that just I'm given some example, like in groundnut, if you see only the kernel portion, it gives 75% of oil, whereas if you are taking the total groundnut with hull, including hull, then the oil content will be, and the percentage of this kernel and hull is given, like 75% of kernel and 25% hull is there. So here, just I mean to say that, so at the time of oil extraction, we need to remove this hull percent, that's 25% in case of groundnut, or rapeseed mustard in case of 18 to 20%, so that we will get the high amount of oil, so that we can remove the hull in case in the decortication process or in the dehulling process. After decortication, after dehulling, this size reduction is given. Because if we are giving the size reduction, then we are just doing a reducing the size so that the surface area is increased, and wherever the separation of oil from the oil seed is facilitated by reduction of the seed in small particle by grinding or the rolling. That is the size reduction procedure. And the cell wall are more readily acted upon by heat and moisture if the seed particles are small. That is what we are doing the size reduction, we are doing the flaking so that the surface area increasing, and because of that, the oil recovery is also increasing. Including the size reduction, this heat treatment is also another important pre-treatment. So whatever we are doing the size reduction of that our oil seeds, the heat treatment is giving. So in the heat treatment, or you can say that otherwise it is called the cooking process, because we are giving some heat. Okay. So in otherwise it is we are calling cooking process. In the cooking process, what happened? Whatever the coagulate proteins present in the seed causing the coalescence of the oil droplet and making the oil permeable. Because of that, the oil flow out easily. That means the oil will come out easily by the heat treatment process. So this process also decreases the affinity of oil of the solid surface of the seed, because of which the best possible yield of the oil are obtained or in the extraction or the expression process of the cooked seed or heat treated seed. That is what the heat treatment weaken the cell wall by cooking and cause volumetric expansion of the droplet, which result in the rupture of the cell and explosion of the soil. So our main intention, that is what, by doing the size reduction, then by giving the heat treatment, we are enhancing or we are increasing the oil yield. That is the intention. That is what the pre-treatment is required before going for the oil separation. So some of the means our own research paper we have done, where we have taken various moisture content, various cooking temperature, various cooking time, and we have seen the oil recovery percentage, also pressing rate and other quality aspects. Okay. So here in the research, we have seen that we are getting around maximum 73% of oils. So at around 9.69% of moisture level of the seed, where it is given heat treatment around 110 degrees centigrade for 10 minutes. Means that is the optimum condition. At this condition, we are getting the maximum oil recovery. So that is what the pre-treatment is required. Okay. So at optimum condition, oil recovery from the cooked seed was 7% higher than the uncooked seed. So this is what from the our research we found out. Okay. So now coming to the next step, that is the most important step. How the after this pre-treatment, how the oil recovery is done. So that is various methods are there. So that I told, maybe expression method, maybe extraction method. So if you are using chemical, that is extraction method, and if you are using the physical means, that is the expression method. So this Ghani, expeller, solvent extraction, and some recent technology that I will be discussing in the coming slide. So coming to the this different traditional method, these are some of the traditional methods. So aqueous method, your hydraulic press, Ghani, maybe animal or power driven, or solvent extraction, the screw pressing. Okay. So here, this aqueous method, that's the traditional method, and now it is, you can say, almost obsolete. Okay, so nobody is using this traditional method. Maybe 1940, 60, in that time it was used, but because of the low efficiency, you can see that. So efficiency is around less than 40%. Okay, because of that, many losses are there because of, and also the quality of oil is not good. Because of that, this nowadays nobody is using this aqueous method. Then coming to this hydraulic press, here also you can see that the efficiency of the oil yield is 50% only. That means another 50% oil is lost in case of this hydraulic press also. So this is expression method where we are doing some physical pressure to the oil seeds, and we are getting out the oil. Okay, so this is also almost nobody is using nowadays. Okay, so now coming to this Ghani, so this is also traditional method. So where the efficiency is around 57%. Again, loss of oil is there, but advantage of this Ghani is the quality of the oil, the good quality of the oil. So nowadays, maybe we are in the Baba Ramdev advertisement, or I can say that the Ghani oil is very much famous in all, particularly, I don't know about the foreign country, particularly India. So we are very much famous about the Ghani oil. Okay, because even if the efficiency is less, but the quality of oil is very good as compared to the other method. So that is what this Ghani oil, nowadays people are again back to this Ghani. Okay, so in the maybe in the 80s, 90s, there is no Ghani, but now before that people are using Ghani, because I remember in my childhood we used to bring oil from Ghani only. Okay, but in between it is gone, and nowadays again, because of the we are mainly depend upon the quality, and we are more require the quality of the food or quality of the oil. So that's what we are again coming back to the Ghani. Again, Ghani are of various type, maybe a bullock drawn or maybe a power Ghani nowadays coming. Okay, so regarding the detailed procedure, how the Ghani is operated, that I'm not going to discuss, but can say that I can say that though efficiency is less, but whatever the oil is there, or whatever the oil that we are collecting, the good quality wise very good as compared to the other technology. So now next one, the expression process, that is the solvent extraction process, where the efficiency is very 99%. You can say that. So 100% oil that we are getting, particularly for the research purpose, we are using this solvent extraction, where we are getting 100% of the oil. Or if you want to know the oil content of that material, then you go for this solvent extraction process, or from the some high value oil, some additional oil, then you can I suggest that you go for this solvent extraction unit. Okay, so whatever this, particularly this solvent, that is because quality is another means problem here, because whatever the solvent is there, that dangerous to handle, or you can say the unacceptable as quite as harmful to human health, and also harmful to the environment, which may restrict its use in the food, cosmetic, and pharmaceutical. This is one of the big disadvantage of this solvent extraction unit. Although it gives higher yield, around 99% or 100% oil. So next one, the most common the oil separation unit is the mechanical pressing. That is what people all about the world, this mechanical pressing is used or being used throughout the world. So it may be a cold pressing or it may be wet pressing. So that is if there is a thermal treatment involved during the operation or the before the operation, like that is the, you can say, wet pressing, whereas no thermal treatments before or after, then that is the cold pressing. That is okay. Whatever I told, the heating treatment, cooking treatments, okay, what temperature is there, then in that condition, this is called you can say wet pressing. Okay, if there is no heat treatment, there is no thermal treatment before or during the operation, that is the cold pressing. Okay, as compared to the wet pressing, the cold pressing oil give a good quality. So this is what the expeller or the most common used machine that is used for the oil separation or oil expression, you can say. So there are various designs are available, like this is one type. So the various components are there. Then you can see the inside part of this screw press expeller. Then other type of this expeller, that is the 4-bolt oil expellers are available. Then 6-bolt oil expellers are available, because here only the capacity vary. Maybe 6-bolt oil expeller, the capacity may be small as compared to means that is small as compared to the 6-bolt oil expeller. Then again, some German design oil expellers are available. If you just find differentiate between those 6-bolt or the screw press expeller, this German design oil expeller, they give a good efficiency. The oil yield is good as compared to the 6-bolt or 4-bolt or the screw expeller. So this is only the difference. So the detail about the principle of this oil, that is the 2-step. It is whatever the oil is taken out, that is a 2-step. First, in case of this screw press expeller, maybe a 6-bolt, maybe a 4-bolt, maybe a your German design oil expeller. First, there is disintegration process where the oil globules are separated. After that, the pressing, that is the top membrane surrounding the oil droplet is exposed and burst under the pressure, thereby the oil is coming out. So this is what the principle of operation. Just I'm just skipping this principle of operation, how this oil expeller is. Then these are some of the important component of the oil expeller: the casing, the screw, check nut. Okay, other things are there. So and this is the screw that is important component of the oil expeller, where the feed section, the conveying the material, coil sheet from you can feed end to your discharge end, and then ram section where the metering or where the you can say the side reduction is occur. Then the plug section where the pressure develop and we are getting the oil. This is what the again different zone: feeding zone, transport zone, compression zone, then extruded zone, then expansion zone is there. So now coming to some of the this is what I described, the traditional you can say things happen in case of oil processing technology. But nowadays some recent advances are also coming up in this oil seed technology. So maybe supercritical CO2 extraction, a tabletop extruder type oil expeller, enzyme assisted oil extraction, then you can say ultrasound assisted oil extraction, microwave assisted oil extraction, then pulse electric field assisted oil extraction. So this supercritical CO2 extraction, you can say this is a green technology, or you can say an alternative method for extraction of the oil from the natural compound. What happened here? Here in this SeCO2, this allow the supercritical CO2 at temperature near room temperature and relatively low pressure. Here, the low critical temperature of CO2 around 31 degrees centigrade, this allow the extraction of thermolayable compound without degradation and the solvent residue. So here the what happened in this supercritical CO2 extraction, the oil obtained by this whatever this supercritical CO2 extraction, these are outstanding quality. The quality are good. The yield are comparable with those of the organic solvent method. That means the efficiency is good, or efficiency is around 95%, in case of this SeCO2 method. So here you can say that this SeCO2 as CO2 extracts are generally recognized as safe, and this is what this SeCO2 methods, they serve as a very promising technology in food and pharmaceutical process. This is what the new or recent advancement or recent technology, people are doing some research on this supercritical extraction technology. So these are some of the figures of the actual photograph. Then coming to this tabletop extruder type oil explorer, this is another, can say, the exactly similar to the what I described in the screw press oil explorer, but it is a small one, very, you can say, handy one. You can keep in your table and you can extract the, you can say, oil. Okay, so maybe the price is around 18 to 20,000. That is also available in Amazon. Okay, so the advantage is that the efficiency here also high. Also, it is there is no pre-treatment is required. You can get cold press oil using this tabletop extruder type of oil expeller. Okay. So these are also the very recent one in case of the oil processing technology. Then some of the also you can say the technology or research is going on based on the enzyme assisted oil extraction, where this this enzyme assisted extraction that is widely accepted as a lipid extraction techniques for obtaining oil and valuable peptides simultaneously with a higher quality. So this enzyme assisted oil extraction, you can say that it is considered to be a green technology. This enzyme assisted EAE, green technology and environmentally friendly method. Here, the enzyme assisted extraction technology use specific enzyme, particularly some enzyme specific enzymes are there. So what happened? Then those are used to disrupt the cell wall of the source material to improve its extraction yield. Okay, by introducing some of the enzyme there, they will disrupt the cell wall so that the oil will come out easily. And whatever the enzymes like cellulase, your hemicellulase, pectinase, and the protease, they are most favorable enzyme for degrading the cell wall on oil sheet to retain the oil globule in the structure. And this enzyme or use of this enzyme reduce the amount of solvent also. That is another advantage, which require extraction and increase the yield of the extractable compound. Then the next recent technology, that is the ultrasound assisted oil technology. Here, this ultrasound, you can say assisted technology, or you can say ultrasound technology that has been employed to extract the oil from various type of oil seeds and other means promising crop. So it was shown to be that shown that it is shown that in various research, the increase of oil extraction yield as well as promote the extraction of the phytochemical also there in case of this ultrasound assisted oil extraction. That means by using the ultrasound assisted oil extraction, we can also increase the oil extraction efficiency or the oil extraction yield. So here, so this UAE or ultrasound assisted extraction of vegetable materials, the result of the cavitation phenomena is enhance the material transformed from inside the cell to the external environment. So here in this process, what happened? The cavitation bubble from in the solvent, and it will burst, the causing changes in the pressure, where pressure and temperature that increase or expedite the mass transfer of the solute in the sample. And you can say the frequency range of this ultrasound assisted extraction is around 20 to 100 kilohertz. And this techniques consume less energy and require less maintenance. And here, in the ultrasound assisted extraction, the key parameter that influence the ultrasound rated extraction of oil seed include the particle shape and size. That is what the importance of size reduction is there. The moisture content, what moisture content of the seed is there, amount of solvent, extraction time, temperature, all depend on how much depend on the yield of oil from the oil seeds. Likewise, the other technology that is people are doing research, that is the microwave assisted oil extraction. So that is whatever the that increase the oil yield and the extraction process rate also. In this microwave-assisted oil extraction, so that utilize the microwaves to increase the effectiveness and the efficiency of the cell to break down. So that once the cell breakdown occurs, then the movement of the oil will be easy. So that is what the principle. And the molecular movement of microwave that produce friction and the heat energy in the material, so that the cell wall and the tissue material will be damaged and the solute can finally come out. That is what by giving this microwave assisted microwave means radiation, so we are just allowing the oil to come out easily. So the next one, the last one, so that is for the pulse electric field assisted extraction. Here the application of this PEF, okay, that is emerge as a possibility to produce a gentle, low temperature and a highly effective process to pre-treat the oil seeds. You can see that it is a pre-treatment process to get the oil recovery. This PF results in the rupture of the cell membrane of the oil seeds when submitted to an external electric field, increase the electrical conductivity of the oil seeds, and then the permeability of the intercellular material is increased. And this PF technology is based on the phenomenon of the electrical breakdown in water, which induce physical, that the shock wave and chemical process that affect the cell, enhance the release of the intracellular components. So based on these effects, so application of high intensity electric field could replace and abrogate the conventional technique in the recovery of the plant. So that is what one scope is there, or this pulse electric field assisted oil extraction till I think when if you see the Indian point of view, still we are not using this pulse electric field in case of oil technology, but people in the other countries, they have already started work to get the enhance the oil recovery from the oil seed using this PF technology. So this is all regarding my thing, and in the conclusion section, I can say that efficient post-harvest technology is important to play an important role to get the high oil yield as well as the good quality of the oil. And the modernization of the oil processing sector is need of the hour, so that to stop the import or to cater the demand of the oil to the people. So this modernization of the oil processing industry is required. Emerging technology in the field of oilseed processing, that I told whatever the recent technology are coming, and the pre-treatment is required to increase the oil yield, and develop novel, low-cost, efficient oil explorer will help to meet the demand of the oil. So this is what for my today conclusion, and this is what from my side. I think I finished in time. Thank you.
Oh, thank you, thank you. No, you finished right on time. Now we'll open it up for discussion. There are a few questions and comments in the chat from Biswajit. Just keep the slides. Maybe somebody might have to refer to it. Just let's hang on to the slides for a bit. So I think Biswajit, you can ask your questions.
Yes,
yeah.
Okay. I had actually asked about the temperature of processing, but he answered that in the next slide. So that has been answered. And the other one on the chat was about it was more of an information that one of our alumni, Kishore Behera, he has an outlet in Bhubaneswar. Yeah, where he is using this Ghani technology for cold pressing oilseeds to get oil. And there are a few others also now in Bhubaneswar. But those are small scale operations. But my question to Dr. Pradhan was that why is it that people prefer, or the commercial establishments rather prefer to go for the other cold extrusion method instead of going for cold pressing or the Ghani method?
Why people are using this other method, Ghani?
Yeah, we're using the extrusion method. Yes, yes.
Okay. Sir, particularly if you see, I told that the Ghani, the efficiency is less. That means the oil loss is there. if you see
Yeah,
the
but the quality is
extruder,
quality is better, is it?
quality is
Quality in
better.
the sense
Quality,
flavor, quality by quality you mean the flavor, not the chemical qualities, is it?
chemical quality, sir. Chemical quality, sir. As compared to the extrusion process or extruder type of oil expeller, where the heat and the treatment are involved, as if you see the quality in terms of flavor, in terms of your chemical stock composition, the quality of the ghani is better, sir. That is, but you need to fulfill the demand of the people, sir. One is the demand of the oil. Another thing is that the efficiency of the oil, because people want more oil, because somebody is doing business, he or she obviously they will want they will get more oil. Particularly if you take the any oil seed, they will get the more oil. They want more oil.
Okay,
So
so
they will go
it's more of a commercial consideration than quality consideration.
yes, sir. Yes, sir. You can say that. But nowadays, because now we are aware of our quality, because of that, now we are going towards this again, ghani.
Right. I think that's all from my side now. Debu?
Dr. P.K. Mishra, you have a question?
Yeah, thank you all. Actually, it is good to see the young alumni in a different institute like NIT. So I congratulate him to be our representative in some non-conventional institutes like NIT. So it is good, and we are proud of him.
Thank you, sir.
So
Thank you, sir.
my
Sir, can I interrupt for a moment, please? Actually, I just wanted to correct you. Dr. Pradhan is in the food processing engineering department of NIT Rourkela. There are a few other alumni also in that same.
good.
Yeah.
Yeah. In water resources, I think maybe somebody there.
No, no, sir. We
No,
have a separate
I meant in the food processing engineering, but yeah, there are others also in water.
Hello.
Oh. Yes.
Hello. Hello.
Yes. We are able to listen.
Okay. Congratulations, Dr. Pradhan.
Thank you, sir. Thank you, sir. Namaskar.
My question just.
I know intimately Pradhan from BTech to when he was in IIT Delhi also. So
Yes.
I always wanted our alumni or my students to be involved wherever I am. So in GIFT also I involved him in our program processing. And many of us also you have visited GIFT. And fortunately today, incidentally, is the foundation day of OUT. I think all of you know it. So we had a good program. And regarding your talk today, it is excellent. And we learned many things. And to be very frank, we are in the old group. And our successors are more equipped and more knowledgeable. So thank you for sharing your knowledge in this platform. Thank you, Devasmita and Vishwajit, and also Sushant for taking it well off. With this, I once congratulate Pradhan and all of you for such
Thank you, sir.
Thank you, sir.
adventure and continuing it every month. Okay,
Yes.
thank you.
Thank you, sir.
So I am having a small question actually. My question part is now still there.
Yes, sir.
I wanted to know because we are now using at home the small expellers that you sowed in between. So what is the percentage of oil extraction from there?
So here 85%, sir. 85% to you can say 90% depend upon which oil seed that we are taking and
Suppose groundnut.
Yes, sir. Around 85%, sir.
Good. So how whether it is a small machine or bigger machine in mechanical expeller, it will be same between 80 to 90% extrusion without this
no, sir.
processing.
Particularly, sir, in this the tabletop that I shown, this is the you can say the recent one here, particular whatever the extruder type oil expeller you are taking, sir, that is mainly the design of screw. Whatever the oil efficiency or the oil recovery comes, that based on the design of screw. So based on the design of screw, the oil recovery depends. Whatever the traditional, you can say, oil expellers are there, like so 6-bolt, 4-bolt, or extruder type, those screw are not means designed properly. So because of that, they have less efficiency, around you can say 75 or 70 like that. But here, the screw design and the other parameters, the RPM, all the heating condition is given in this top tabletop model. Because of that, so efficiency is increased, sir.
Okay, good. Thank you.
Okay, thank you, sir.
And next question is from Dr. S.K. Satpathy. Are you
Yeah,
there?
good evening to all.
Yeah.
Good evening to all.
Yes, sir. Good evening,
Am I
sir.
audible?
Yes, you
Yes,
are.
sir.
Yes, sir, you are.
Yeah. Yeah, sir, I am a faculty in Central Agriculture University, Manipur, Imphal. And Professor Ramchandra is actually my immediate senior. And we are Guru brothers also in Ph.D. So
Okay.
I
Yeah,
congratulate
like that,
Professor Pradhan for this wonderful talk. I had a small query that apart from the size of the expeller, what is the technical difference between the traditional expellers and the tabletop screw expeller? I think that he has already answered that based on the screw design. So, what is the constraint that we are not able to adopt a proper screw design in the traditional expeller?
Yeah, actually, I just keep that. If you have seen my slide, Sangram, okay. So there is the configuration of screw is there. So here the configuration, detailed configuration is there. Okay. So the including this compression ratio. Okay. All the design. So there is also the flight height. You can say that the flight width. What is the your root diameter of the screw, what is the diameter of the screw, all these things actually vary. So that design need to be calculated and that design need to be done properly. Otherwise, efficiency will less. So that is what, if you compare that traditional one, the bigger one, or compared to this small tabletop one, so this compression ratio or the flight width, the gap, the root diameter of the screw, other things, okay, so those are properly done in case of this handy one. Because of that, and also the pressure, including what happened here, the temperature is given, the RPM is also given. Okay, so proper RPM is also required. Those things are optimized in case of this handy one. But in case of your bigger one, like your 6-bolt, 4-bolt, that is, those are not optimized. Okay, so that is what the difference is technically. And because of that difference, we are getting higher, you can say,
Is that okay,
thank you.
Dr. Satpathy? Your question answered?
Oh, yes, sir. Thank you. Thank you very much.
Okay, no problem. Next question is from Jigyasa. So you can ask your question, Jigyasa, because that's an interesting question. Hello?
Yes, sir.
No, Jigyasa, I'm asking. Jigyasa, are you there? Yeah.
Good evening, sir. Good evening, Pradhan, sir. So the presentation was really very informative and nice. But in addition to that, I have a small question that there are multiple cryogenic grinding methods coming up in the field of oil extraction process, mostly in essential oil extractions when we are going for any bioactive compound extractions. So, is that also included while we are going for this pulse or oilseed extraction or any of the cash crops, or is that limited only for the essential oil extraction?
Yeah, Jigyasa, if you see, just I'm happy to say that I have a patent also under this cryogenic thing. Not exactly the oil explorer, but cryogenic grinding part. Okay. So here I told that in the pre-treatment, one decortication part is important, right? So in decortication part, what happened? If you decorticate the oil seed, there are various type of frictions available. Frictions are there. Because of that, heat development is there. Once the heat development is there, means the quality of the oil seed is deteriorated. Okay, because of that, if you are giving the cryogenic, maybe side reduction or the cryogenic decorticator that we have designed or pattern, I have also one pattern on that. If you are doing that, the quality of the oil or the source of the oil, that will be good. And definitely, so that will affect in the oil recovery. That means in the quality of the oil. Okay, so that is what the cryogenic thing people are doing to get the good, can say, quality of the oil. Not exactly, I'm repeating it, not exactly the increase the efficiency of the oil, but increasing the quality of the oil. This cryogenic part is coming up. Is that, am I okay? Yeah, Jigyan sir.
Yes, sir.
Go ahead. Go ahead.
Yes, sir. With addition to the quality part, sir, the table you showed for the cooking time, and there was a temperature and cooking time, and for how many minutes the operation was carried out. And in the tables it was shown, perhaps if I'm not,
10 minutes.
so
10
can you
minutes.
please show
10
this
minutes.
slide?
Yeah, 10
Sir,
minutes.
with
Yeah.
higher,
That is,
with lower temperature and higher time, actually the moisture content was the minimum in of 5 point some percentage.
9 point something. This
Uh,
one
uh,
is
Yeah, can you go to the full mode? Yeah.
then the 12th slide, the next one.
yeah, coming. This one, right?
Yes, sir. So in there, with cooking temperature of 130, the moisture content, the final was 5.01. So the initial was 7.22, but it got reduced to 5.01, if I am interpreting it in a correct way.
No. The moisture content of sample is initially 7.22 to 12.16. We have a different sample. The initial sample lot has 7.22 moisture content dry basis, then 9.69 lot, then 12.16 lot. So around 3 lot of samples are taken. So those samples, they are pre-treatments are given. Like we have taken 50 degrees centigrade, 70 degrees centigrade, 90 degrees centigrade, 110 and 130 degrees centigrade with different time. That is 5 minutes, 10 minutes, and 15 minutes. Based on that, we have optimized and found that at moisture of 9.69 with a cooking time of 10 minutes with 110 degrees centigrade, it gives 73% oil recovery. It again, Jigyasa, it is particularly for the this particular seed. Again, what type of seed that you are taking, based on that, this condition will vary.
Okay, sir. Thank you, sir. This was actually my doubt, because when we are going for Jatropha seed, it's basically for any of the green technologies, as per my knowledge, for any of the engine operations. I may.
Yeah,
Or
it's used for biodiesel. It's called biodiesel. Yeah,
but
you're correct.
yes, sir. Yes, sir. For any of the
Jatropha
operations.
seed only a seed I'm taking. You can take mustard oil, or you can mustard seed, you can take groundnut seed, you can take any, just I have, because I was working on Jatropha seed that time, I have done this oil. Okay, you can take any type of seed. Based on that, your condition will vary. This, the oil recovery, the moisture content, the cooking time, cooking temperature, those vary based on your which type of seed that you are taking. That is what I told, the efficiency may vary from maybe 70% to 75%, or you can say 80 to 85% to 90%. That is what I told.
So, okay. Yes, sir, I got it. Thank you, sir, so much.
So Dr. Pradhan, when we say cryogenic grinding, are we talking
Yes, sir.
about temperatures below 0 degrees Celsius?
Not exactly, sir. Temperature below maybe 4 degrees centigrade.
Yeah, temperature below 4 degrees centigrade. Okay.
Yes, sir.
So it is just meant to harden the husk or the seed.
Yes, sir.
Harden the seed so that it is efficiently grounded rather than being mushy. Is that what I understand?
Exactly. That is one point, sir. Another point is that whatever the heat developed, because in the heat, I think Jigyasa correctly told, some bioactive compound or some of the thermolable compound degrade.
Okay.
Because to reduce that, also cryogenic is helpful.
Okay. Now it is Dr. Dora Babu, your question, please.
Good evening, sir. Good evening, everybody. But actually, I missed a major part of this presentation. I joined at the last stage, but still I had some of the questions. Number one is whatever I knew about oil extraction, I was told that we do it in the two stages. Initial stage in the cold pressing or whatever pressing, we are getting about 70% or 60, 70 or 65, whatever oil we are getting. Then we are getting the oil cake. This oil cake is being taken there for solvent extraction. Directly from the seed we are not taking, because we are doing in the two stages. And in soil extraction, solvent extraction, we are getting whatever the rest oil is available in the cake, and we are making the cake to de-oiled cake, like de-oiled groundnut cake, de-oiled teal oil cake, de-oiled. Those are after solvent extraction we are getting that. This was under my impression. I think he can clarify whether we can do both the things at a time in solvent extraction. What I was told in the present industries I have visited, they said that some industry go for the cold pressing and taking out the oil cake, and they used to sell the oil cake to a different solvent extraction plant. And the extraction plant, they used to purchase the oil cake and they used to extract it, because both are having some cost benefit analysis. I hope this is, I don't know, initially I was not there in the presentation, so I couldn't know. I feel this is the correct method, na?
Okay, sir.
That is
sir,
one.
It is the correct one. But the thing is that we cannot mix that. Suppose I am taking example of groundnut, that's most common. So groundnut also, whatever the groundnut are expelled. So we are getting one side the expel oil, that is one part. The byproduct as a cake. The byproduct as a cake. But I told that around 70, suppose 75% we are getting the oil. Then rest 25% is remain in the cake.
Inside the cake.
That 25% you can extract using the solvent extraction process. Again,
yes.
if you are going for the solvent extraction process, sir, because that oil quality is not good. I told that the chemical that you are using, so there's a harmful to us also, to environment. Okay, because
hexane,
of that.
Hexane they are using, no?
Yeah, hexane. Yeah, sir. So because of that, so we cannot add that oil to that edible oil. But whatever the oil that we are main product we are getting, we cannot mix that. Maybe that oil can be separately sold, and after de-oiling, that de-oil cake again can be taken for the protein extraction, again can be taken for the bioactive extraction component. Maybe some other briquette, other thing can be done with those de-oil cake. But again, those two type of means oil from the cake and oil from the original thing, those we cannot mix that. If you are mixing, then obviously your efficiency will go, but again, quality of the oil will deteriorate. That is the main reason where we cannot mix those two oil. Okay,
that is what I was knowing. And second is regarding the cryogenic grinding, what it was discussed recently. I have come across such a situation. In one ITC plant, one of my students, he visited, and they showed a particular problem about the grinding of these spices, this garlic, ginger, and the turmeric, etc. So they faced a lot of problem. I had a discussion with one of my close classmates who was a food processing expert. He pointed out this cryogenic grinding at one place in India, it is being done. This is particularly, he said that it is, you are protecting the flavor, smell, and everything in that cryogenic grinding by where it is being cooled it is grounded at a low temperature. It is not below 0 degree, but it is cooled at a low temperature so that it extracts the entire heat that is exhibited during the grinding, and the quality of the spices, that becomes very good. Now we are talking about the oil seed. Maybe this is an extra part within the same cryogenic grinding system.
Yes, rightly said, sir. Only in case of oil seed, only to that restrict the heat. That is what the pre-treatment of cryogenic thing is given. Particularly, whatever the cryogenic, I have particularly rightly said, sir, to keep
protect,
that flavor, to retain. Yes, sir. Yes.
Retain that flavor and protect those things.
Yes, sir. To those is mainly spices industry nowadays.
But
using
in India,
those types.
only recently, the cryogenic grinding has entered into India. Very few plants they are doing.
Yes,
It has
sir.
not gone up
Yes,
to
sir. Yes.
taken up in a large way. I hope
Yes,
later
sir.
on time will come when everybody will try to tell you that.
Yes, sir.
Okay,
Yes,
thank you.
rightly
It's a
said.
nice presentation. I must, if I can get the entire thing, at least I can refresh my knowledge. Most of the things I
Sure, sir.
missed in
Thank
it.
you, sir.
Yes, sir. It will be posted on YouTube, and a link will be shared with everybody.
Okay, okay. Thank you.
So, Prabhat Babu, your question is next.
Hi, Mr. Pradhan, in Bhubaneswar, what I have seen, 3 plants are here. 2 are in front of our implement factory, in front of implement factory 1, and while going from implement factory to agro industries, another within 200-meter distance. And our 88 batch Kishore Behra, he has also cold press oil mill in his shop near Barmunda. So the cost of the cold press oil they are now taking from us is 300 rupees or 350 rupees per liter or per kg. Whereas in market we get it within 150 rupees per kg or per liter. The thing is that the cost is becoming double. Will it be then popular in the market if the cost becomes double? And you are telling that from cold press we are getting 85% extraction and another 15% perhaps in the oil cake. So how can it be, the cost will be reduced? What is the method we can adopt so that the cost can be reduced from 100 means it is 150 and the cold pressed one is 300 or 350. So double, the rate is double. How can we reduce the rate? That is my question.
It's a particularly what about the market available oil? So I don't know exactly if you are purchasing the same oil, means same cold press oil from the market and same from the that Kishore sir or whatever maybe. Okay, so
no, in the market we are not getting that cold press, but we are getting the such as let us tell about the Ramdev Baba's oil. It is now 150 rupees per liter. But from the cold press extraction, what we get, it is 300 or 350 per liter. So it is not possible for a consumer to purchase in double rate. How can it be reduced? How the cost will be reduced? You are telling that 85% extraction is being done in the cold press oil. If 80% we are getting, then the cost, how the cost has become double? That is my question.
yeah, so maybe cost the 350 cost the production of that unit maybe not so high as compared to the bigger industry like Ramdev Baba. That is my means I am thinking.
Yes, you are right. Yes, you are right. Because those are small oil mills and they are just doing it on the roadside in small shops. So they are it is not commercialized, but they are selling kacha ghani tel. They are telling and they are selling, but the cost is double.
Hello.
Yes.
Can I intervene? Hello.
Yes, sir. Yes,
Please
sir.
go ahead. Please go ahead.
Okay. The cold press oil, let me, Dr. Pradhan say in groundnut, if you press 1 kg of groundnut, what is the percentage of oil we are getting?
Around
35%?
yeah, around 40%, sir.
40%. So
Yeah.
if you want 1 liter of pure groundnut oil, cold pressed,
Yes.
that means you need 2.5 kg of groundnut seeds.
Yes,
What
sir.
is the
Yes,
cost
sir.
of that? So if you take into that, the cost of cold pressed will be definitely higher, and the cold press oil is not for common consumption. Commercial we are getting, it is mixed with mineral oils, and for common people, they want refined groundnut oil available in the market at 120, 30, 40, 50 rupees. And
It is 85% you told?
the different class of people, those who want actual oil. Again, I saw one information. After cold pressing also, if you store it for a month, then there will be some problem. So they follow another process after the cold press and get very refined oil. You can also use it for 2-3 months. So that is why the cost will get more higher. And that is why this cold press and refined further is for higher class of people who can pay for that, for good health. And ultimately also their consumption will be less. This market oil, what we are getting, say 100 ml for one use, we will not use that 100 ml of the cold press refined oil. We will use less. That may give some balance, but not the cost balance. Okay, thank you.
Thank you, sir.
Yes, that is one marketing strategy also, saying that good quality oil, because in the market, that's what I asked, sir, which type of oil that we are purchasing from market. So obviously, if the quality of if you see any food, if the quality is improved, then obviously the price is also improving. So that is one point, why the price is more. Prabhat sir.
So Prabhat sir, are you done with your question? Okay.
Yes.
So next question is, actually there was an intermediate question. I'll just quickly put it forth from Dr. P.K. Mishra sir. It's asking extraction of cold pressed at home. Is it 85% or 40%? That's all he's asking.
No, sir. The groundnut contains 40% oil.
Okay.
But the efficiency of the machine, cold press machine, is 85%, sir.
Okay. The last question will be from Jigyasa.
Yes, sir. So in slides, you have mentioned that this extraction process and then written as green technology. So how we are defining it to be green? Like on what basis we are defining the processes to be green?
Okay, Jigyasa, if you see hexane is harmful to human being, as well as hexane is also harmful to your environment. Whereas, if you see that supercritical CO2, carbon dioxide, it is not harmful to human being or not harmful to environment. Because of that, this supercritical CO2 is also called the green technology. Other than this supercritical technology, also these enzymes, whatever the enzyme that I told, so those are not harmful to us or not harmful to the environment. They're not means giving any effluent or anything which harmful to the environment. That is what I told. It's a green technology.
Okay, Jigyasa?
Yes, sir. On the basis of green, actually, there has been some work on hydrodistillation extraction. So for hydrodistillation to work, they are working with the solar, like the heater. One part is they're heating using the natural. So somewhat the machinery thing is working for the green, or you are so here you are trying to say the chemical basis you are trying.
No. What about the solvent? What about the this chemical that is being used in case of technology, oil extraction technology? If you compare particularly the hexane as compared to the carbon dioxide, hexane are harmful, whereas carbon dioxide are not harmful. Machine part is not coming. Yeah, machine part is not coming.
Okay, sir.
That solar energy that you can use as a green technology, but that is in spite of electric, you can use solar energy. That is good. That is means advantages to the environment. But if you whatever green technology I told, so that is based on the chemical that is being used.
Okay,
Yes,
Jigyasa?
sir. Yes, sir. Yes, I got it. Thank you, sir.
Okay, so it's 8:37 p.m. and thank you all for staying for 7 more minutes today. And my gratitude to Dr. Ramchandra Pradhan, Professor Ramchandra Pradhan, I should say, for the talk today. It's an excellent talk. I had many questions, but I saw that many others are interested, so I gave up my questions. So we'll talk some other time.
You can follow up on CAET group.
Yes. I will ask you on the CAET group as long as you are active there. But I know you are a busy person. Sometimes people don't respond.
No, sir. I'll be responding. No issue.
Okay. Anyway, thank you very much for today's presentation. It was awesome, and I look for. Please join us for the future presentation so that we can encourage this tea talk.
Yes,
Forward, and please suggest others to give a talk so that we learn from their experience. I got Narendra today scheduled for November. I want somebody for December. I think Prabhat Babu will talk in December, right, Prabhat Babu? He's laughing.
Yeah, we have the calendar, sir.
It's December of 24 or 25?
25.
Yeah, we are talking about 25, right? That's what.
Oh my
Yeah.
God. I'm in July 25.
Sorry, somebody was speaking.
I'm in
Thank-
July 25. That's certain.
Yes, you are in July 25.
Just an
Yes.
information, sir. Biswajit Acharya, sir, the person behind our department, sir, he has course development in other infrastructure development. He has many roles in our department, sir.
Thank you for that, but that is absolutely
Not only your
exaggerated. I was
department,
there in that
Dr. Pradhan.
first study
Dr.
of
Pradhan.
your.
Biswajit. Hello.
Yes, sir. Yes, sir. Yes, sir.
Not only IIT and NIT Rourkela, he is involved with also in GIFT as an.
Yes, sir. Yes, sir. I know that. I know that, sir.
No, because of his experience in the industry. We have
Yes,
taken
sir.
him. We have taken industry, academia,
No,
and also others.
yeah,
So,
Dr. Swain, Dr. Pradhan, I'm thankful for that. But I mean, Dr. Pradhan, I must say that you are exaggerating the thing. I've just been maybe once or twice to NIT Rourkela. I have a soft corner for Rourkela, of course. That is my birthplace. But other than that, I'm trying to be getting involved in academics now. Yeah.
That is why you are not Acharya.